All right. Last day of Unit 1. Yay! All right, so we are talking about equivalent expressions. So an equivalent expression is two or more expressions that have the same value for every numeric value of substitution in the variable. Which I'm sure probably sounds like googly gook. So basically all that means is no matter what number you plug into your variables in both of the expressions you're looking at, or all three of the expressions that you're looking at, it will be the same. That is what that is saying. So no matter what the number, it's always going to be the same. And so like terms means that they have the same variables, or variables, I should say, with the same exponent or exponents. So like terms means it's the same variables, same exponents. So that is what we will be working with today. So here we have some expressions. And what we're going to do is we are going to simplify these down as much as we possibly can to find other equivalent expressions to this. So like this first one, what I'm going to do is I am going to distribute my 5. So 5 times 2x is 10x. 5 times 1 is 5 minus 4. And then I'm going to do the 5 minus 4 because those are like terms. So that's going to give me a 1. So now what happened is this expression that I began with and this expression here, oops, didn't mean to cross my 1, those are equivalent. So when I simplify an expression, it gives me an equivalent expression. All right, so like this next one, same thing. So I'm going to distribute this 4 up here. So 4 times 3x is 12x. 4 times 1 is 4 minus my 2 over 2 minus 5. So now I'll subtract my 4 and my 2 right there. So 12x plus 2 divided by 2 minus 5. So now I'm going to just divide by 2 here. So that gives me 6x plus 1 minus 5. 1 minus 5 gives me 6x minus 4. So again, this is equivalent to that I started with. And each step in the process is also equivalent. Here, distribute 16x plus 26. That is equivalent to there. So we can create equivalent expressions by simplifying things down. So simplifying as much as we possibly can. Now, sometimes we need to test to see if things are equivalent. So there's a couple of different ways that we can test for equivalency. One way would be to simplify each expression as much as you possibly can. So if I'm looking at my first example, my 2x plus 4, there's nothing I can do there. I don't have any like terms. There's no x's, there's no other numbers other than 4, no constant terms as we call it. So that's going to stay the way it is. However, the other one, I can distribute my 2 here. So that gives me 2x plus 4. So now those are the same. So yes, these are equivalent. So testing for equivalency, you can just try to simplify both to see if it's equivalent. So again, next one, I can't do much here. There's no like terms. I can multiply my 1/3 over here. So 1/3 times 9 gives me 3x. 1/3 times 12 gives me 4. And no, these are not equivalent. This one had a -5. This one had a -4. So no, it's not exactly the same. They're not identical, so not equivalent. All right, before my equal sign or my comma here, I can combine these two, so I get -5x minus 6. Over here, I'm going to distribute my -1, so I get -5x minus 6, and those are the same. So yes, these are equivalent. We do have to write the yes, no's, because it asks us, are they equivalent? So you got to actually answer the question. So we would answer these ones with a yes or a no. All right, let's take a look at the back. Our other way we can test is to plug in the same value. So I could pick any number that I want. So like, let's say for the first one, I'm going to pick x equals 2. So my before the comma expression, I'm going to plug 2 in for x. So 2 times 2 gives me 4. 4 plus 4 gives me 8. Over here, I'm also going to plug in a 2 for x. So within my parentheses, 2 plus 2 gives me 4. 2 times 4 gives me 8. So yes, they are equivalent. When I plug in that number, I get the same value back. All right, let's see here. Let's use x equals 0. We could use 0 to test. So 3 times 0 minus 5. So 3 times 0 gives me 0. Minus 5 gives me -5. Over on the other side, that would end up being 9 times 0 minus 12. 9 times 0 gives me 0. So that's -12. 1/3 times -12 gives me -4. So no, they are not equivalent, which is exactly what I found on the front. These are the same expressions on the front. I'm just testing them using the other method. All right, last one here. Let's use x equals 5. Why? Because I can. It doesn't matter what number you use. I generally, as you can see, I try to keep them smaller. You could use like 100 if you wanted to, but then that's just really going to give you some big numbers, which is not necessary. All right, so I'm plugging in 5. I get -25 plus 1 minus 7. So that gives me -24 minus 7. So that's going to give me -31. All right, over here, let's plug in a 5. 5 times 5 plus 6. 5 times 5 gives me 25 plus 6. 25 plus 6 is 31. Times -1 is -31. So yes, they are equivalent. So equivalent just means that they have an equal value. So we can find it by simplifying, seeing if they're the same, which they were on the front side. We can find that by plugging in a value. It does not matter which method you use as long as you use one of them and understand equivalent expressions just mean that they are equal.